Hello and welcome to another tutorial. So this is the fifth part of the AI series. So previously what we had gotten set up was infrastructure for our debugging system, for our state machine setup. We'd also gotten the basic sort of framework for our goals and actions, as well as our brain that handles the planning of those actions. So what we're going to be focusing on now is actually getting some of those actions implemented. So similar to the other parts of this project, in the description you will actually find 3 links in relation to the code. One is to the code as it is at the current point where I'm beginning this tutorial. The other is going to be the code as it is at the end of the tutorial, and the final one is a link to the completed package that has all of the code in it from the entire series. So all of those are available in the link below. So let's dive on in. So what I want to focus on this time is getting some of our actions and things like if that's set up. So for this, I'm going to be working in the GOAP example folder here. So I'm going to create a folder for our script, and then we're going to create another folder for our goals and our actions. So, okay, a couple of ones that I want to go and create to begin with. So the ones we're going to implement today, I want a GOAP action, and we'll have idle, and we will also have a, once it just finishes, a GOAP action wander, because we want to be getting our navigation side of things up and running for this. So I'm going to create the corresponding goal for that. Oops, not a new folder. So we'll have a GOAP goal idle, and similar thing for wander. Now there will be some specific stuff we need to set up in terms of additional scripts, and that's okay. Those are straightforward to get up and running. Now, as a beginning point, in terms of what we'll be using for the AI character, I'm actually going to bring in a simple AI prefab, but I'm actually going to then unpack that because I'm going to create a new prefab. So we'll unpack that completely, because for this GOAP example, there's going to be a base prefab that we have. So hybrid GOAP AI. So that will be our base one. We'll be adding a few things to this. So the way this setup needs to work, all of those things that are already there, those are all good. But what I want to have is my various goals and actions will be attached to that. And I need the brain itself. Now for that, our base GOAP brain was abstract. So I'm actually going to create a GOAP brain wrapper. And this will be an actual concrete implementation of the GOAP brain. We also will have the navigation interface. So I want to create a concrete version of that as well. So we'll have a GOAP navigation interface. So then our GOAP AI is going to have a brain wrapper, a nav interface, and we're going to bring on our goals, and we're going to bring in our actions like that. So now we can start to get these set up. I'm just going to save this scene so I make sure I don't lose anything. So, okay, let's dive in and start to get the different components of this up and running. So I'm going to close all of these other ones. Let's go for just clearing everything out, because I want to make sure that I'm only keeping track of the ones that I need to be updating. So we'll have the actions, we'll have the goals, and then these ones we will also need to get up and running. So, okay, good so far. I want to actually start with the goals. I think the goals are a good point to begin with because they're pretty straightforward. So idle, that's going to inherit from GOAP goal. Now this is not going to initially find it because we need to be bringing in using hybrid GOAP, but we can see it's not appearing there. And the reason nothing's appearing or populating there is if I go and check, I just want to undo this so it's not going to be grumpy at me. If I go and check the assembly definition here, you can see we don't have all of the assembly definitions properly linked up. So I need to add in our hybrid GOAP, and I need to add in our state machine. I don't know why it's got a couple of ones that are weirdly empty there. That's strange. So make sure that's linking to our common core. Actually, what I'll do is I'll revert and remove those ones. And then add in our hybrid GOAP, like that. And we will also add in our state machine one, because I want to make sure we've got that too. So that's good. That should mean here I can actually now have GOAP goal base. So that's good. Can nuke those. And then if I just tell it to implement the abstract class, all it's going to do is have the prepare for planning. So the goal for prepare for planning is to set our priority. Well, this one is pretty straightforward. Idle, its actual priority, I'm going to go for that being goal priority, and we'll say minimum +1. So the idea being we have just a very small increase in the priority. Now, if we go to where this priority is defined, you can see we actually need to change this to get and a protected set, like that, not audio settings. I have a tendency to go and do that. So protected set, and I will initially set that to do not run. And while we're at it, we will fix up this to be our game object name. So that should be, actually, not the game object name, get type name. That's what we actually want there. So that's good for idle. Idle goal doesn't actually need anything else. Wander goal is not going to need much more than that. So we have GOAP goal base. It's going to be quite similar. Wander again should be a pretty low priority. So all I'm going to do is say, well, the priority is ambient. Now, there will be other goals that we implement at a later stage that their priorities will be dynamic, but for these, they don't need to be. So that's it for the goal. The goals intentionally do very, very, very little. So let's then get up and running things like our action. So our GOAP action idle, well, that's going to be a GOAP action FSM. Can nuke everything there like that. We can tell it to implement everything. So the cost, well, idle, we want it to always be able to run. It should have essentially no cost. So we'll allow that to always be super cheap to run. We do want a couple of configurable parameters because it should have like a minimum and maximum wait time before it decides that it's done. And a max wait time, default it to 10. So, okay. In terms of populating the supported goals, well, that's pretty straightforward. Supported goals, or supported goal types, becomes a new, and we just provide type of GOAP goal idle, like that. Now we might need to explicitly say system dot type and that it's an array. So that's all the populated one needs to do. In terms of the required resources, well, this is going to make use of the legs and also the torso. And in terms of the finite state machine, really straightforward. So we have access to our linked state machine. We can just add a state, and there will be a new, and we already have an SM state wait for time, and we give it our min wait time and our max wait time. We don't need to really set up any explicit transitions, so I'm just going to add in the default transitions, and that's going to go to our internal state finished and our internal state failed. So for our idle, that's actually all there is to it. So again, doesn't need a huge amount of logic there. Now, I wonder, that one's going to be a little bit more involved. There is a bit more that we need to actually set up for Wander. So if we go to our Wander one, and again, this comes off of our GOAP action FSM. So with the Wander, there's going to be a few settings that we want to be able to control. So we want to be able to control things like our minimum Wander range. Might set that to 10. We want to also be able to control things like our max Wander range. We want to have, when it wanders to a location, that it just waits there for a bit. So it'll have a min wait time, let's say 4. And unsurprisingly, we'll have a max wait time as well. So we'll say 8 seconds. When it's searching for a location to wander, we need, it'll randomly generate a point, but that location it generates might not actually be on the path network. So we need to be able to sort of search for something nearby. So I'm going to have a navigation search range. So it can search up to 5 meters. And we want to be able to control how precisely it moves to that location. So we want to have control of our stopping distance, which will default that to 10 centimeters. So not a huge distance, but allowing a little bit of a leeway there with it. So we can tell it to implement everything. Now, for the cost, I'm just going to always return a fixed value. Again, Wander should be a pretty low cost. It shouldn't be free because it's not free, but it is an intentionally low cost. We could make it 0, but I think we want to keep idle at that sort of threshold below it. Resources-wise, unsurprisingly, it's going to be legs and torso. Most things are going to be that combo of legs and torso. It's only sort of things like our lookat that the lookat would use, just the head resource. And if we had something that was combat, then that combat one would likely use all of the resources. So our supported goal types is a new system.type, and we get a type of, and we get our wander goal like that. So the FSM configuring is actually really the main thing that we need to be doing. The other thing that we're going to need is to be able to generate this wander location, and I'm actually going to implement that first. So what I want to have in terms of its sort of structure is I want to be able to tell it, so this is going to be able to get a wander location. So it's going to be get wander location, like that. Now, we may, like in terms of accessing our current location, we know we could just go game object transform position, but what I want to actually do is be retrieving things like that from the Blackboard. So on a vector3 current location, and we'll use our linked Blackboard, and we get a vector3, and we know we have common core names, and we have our current location. So we can pick a random direction and distance in relation to this. So we pick random direction and distance. So the angle is a random range from 0 to, because we'll be working in radians, we do pi times 2, like that. For our distance, it's going to be a random dot range between our min wander range and max. So that's good. So we generate a position. So our vector3 wander target, we started our current location, and then we say wander target dot x, and we add to that distance times by mathf sine of the angle. So that offsets it in one of the axes. And then we do a very similar thing in z, except rather than sine, we do cos, and then we return our wander target. So that gives us sort of the core logic there for that. That's going to be tying in to our state machine. So this is what I want to configure next. Now the state machine, I'm actually going to need to create a bunch of new states here, and these are going to be ones that work with the navigation side of things, so they work with the navigation interface. So we're going to get those set up now. Okay, so with the state machine here in terms of what the behaviors are going to be, so this is where the sort of more hybrid aspect of the scope setup comes in. Up until now, it's largely looked like the monolithic GOAP, but the state machine aspect is where the fine-grained and reusable components come in, and this is where I found it actually works quite well. So this is where I want to break down that process of what happens when you're wandering into those individual states. So I don't actually have these states created yet. We're going to set those up in a moment. But first thing is it's going to need to pick a location. So it's going to, we're going to have an add state to this. And I'm going to, even though the class doesn't exist yet, I want to have a state that what it does is it calculates a move location. So I want to have calculate move location. So the idea behind this state is you give it a location and it finds a location on the navigation mesh. So what I'll do in terms of kind of the things that it makes sense for this to be provided, I want to give it a navigation interface. So we have our navigation interface already here. So we have navigation. I want to give it stuff like the search range, and then I want to give it a way to get that initial location. So that's the structure that I want for this. Calculate move location is going to take in our navigation interface. We tell it how far it can search. We tell it, here's the function that'll give you a location. So that will pick a location. Then I need to move to it. So I would have a state move to location. And that's going to be a linked state machine. We add state. And this one is going to be an SM state. And this will be move to. Now again, this is going to need our navigation interface. And this is where the stopping distance gets used. So, okay, we can pick a location, we can move to a location, and then we want to wait there. Which this one, we've already got support for doing this. So we would do linked state machine, add, and our SM state. Wait for time, and this is where we have our min wait time, max wait time. So far so good. That needs a new. Then what we need to do is we need to add transitions to these. So, okay, well, the pick location, we only need to add a custom transition for if it succeeds. So we'll do a new SM transition. We check the state status. If it finished, well, then we can go to our move to location state. Zoom in a little bit. So if it finishes successfully, it goes to move to location. Move to also needs a transition. So this is one where it would be handy to have just one that's monitoring if we've finished the nav mesh move. So that's the other class that I want to have, is a SM transition, and this will be finished move. So we're creating a new one of that, and that also is going to need that navigation interface. So navigation, and then that goes to our wait state. And because it's fine for us to add in the default transitions, we'll add those in to our finished and failed like that. So that's what our state machine looks like. So we've got these additional states we need to now set up. And those are pretty straightforward for what they need to do. But let's get those up and running. So these are ones that they're kind of ones that I think are fine to actually have here in the base set of stuff, because they are doing some common behaviors. The thing, though, is we'd need to check where we put our navigation interface. So we can see the navigation interface is currently in this hybrid GOAP one. It's not in our common core. So what I might do is I might actually move this navigation interface over to common core, modify this, and it's something where, and this is the thing, it's of two minds of where we could actually sort of set this up. Moving it into common core, I think is going to actually work a little better. So it's going to make it a little bit easier for working with it. And it makes sense for the state machine system to be able to have direct access to it. And Unity is taking its time, so we're going to just jump ahead through the miracle of editing to when I can actually edit this file. Okay, so Unity's decided to stop being silly, and I'm going to change the interface of this. I'm going to rename this. I don't know how well the rename will go, but we will see. Visual Studio obviously got quite grumpy with a bunch of that. So that's renamed. There's going to no doubt be a lot of things grumpy at me about that change, but that's okay. I created the state is going to get created here. Yep, that's very grumpy. Let's try again with actually loading up our wander action. Is the challenge with renaming things that sometimes stuff gets very grumpy. I do want to check that navigation here. Okay, it did properly rename that, so that's actually good. So what that means is in our states here, I can create a new state that is going to be calculate move location. We also had our move to, so we'll set that up. Open up both of those because we're going to configure those in a moment. And then I want to get our wander one and this transition here. And we'll get it set up also. So I originally, in my initial version of this, I hadn't actually put these in the state machine for stuff, but I think it actually makes more sense for it to be in that core basis sort of one there, because that's the whole point of having the navigation interface, is it makes it possible and easy to be doing like of that. So, okay, this is coming off of our state base. This is going to, in terms of constructor, so yes, we will have that, but what we will also have with this is we know it needs to be given the navigation interface. So nav interface. We also know that it was being given the search range, and it was being given a function that would return a vector 3. So we can do, because it's just doing a return, we can do a system func, and that's a vector 3. And this is our in get search location function. So that's good. Now we have the base, so I want to also make sure I've got support for string in custom name, just in case we wanted to override this for anything. So, okay, that's good. The navigation interface is something that we will actually cache. So, navigation, cache that. The search range is one that we will also cache, and that function. So our system func for the vector 3, not vector 2, vector 3, and we'll just make sure we're matching the name. That. So I just wanted to get these bits set up first, because the constructor matters. So that, oops, and that should be vector 3. So that's good. Now we can have it implement the actual essential stuff for the state. So we can let it implement those bits and pieces. So exit internal doesn't need to do anything. So then for the tick internal, we don't need to really do much here. What I would actually just do is we return whatever our current status is. We're not doing anything in the background here, so there's nothing we need to actually do. Then in our onEnter internal, and what I would do is our vector3 move location is going to be, we run our get search location function. Now that could give us back an invalid value. So if move location is our Common Core constants invalid vector3 position, then we're just going to immediately return failed. Now that's good so far. Now I want to know who the owning AI is. So I'm going to retrieve self. So for retrieving the owner, that is something I could get directly from the Blackboard. I could say, okay, well, get a game object, and what I want to retrieve is Common Core constants and, Common Core names, self. Now this is something that a lot of states are going to actually be doing that. So this would be a really handy thing to actually bring into our base state. So what I'm going to do is go to state base, and I'm going to give this a function, protected, and we'll make it game object, and we'll have it be get owner. And what you have to provide is a Blackboard, like that. And the logic is just going to be turn, just because rather than having to make sure write this in every single state correctly, it just makes it a little bit easier. So what I can do then is I can just go get owner and give it the Blackboard, like that. So it just makes things a little bit easier. Then find the nearest valid point, or navigable point. So what I would do is say, okay, well, move location is navigation. Find nearest navigable location. We have our mover. We already have the move location as our search point, and we have our search range. Now again, this could fail. So if it fails, then we return failed. Otherwise, we're going to return that we succeeded. But I also want to store that move location somewhere. So what I'm going to do is say in Blackboard, and I'm going to set, and we're setting Common Core names move to location to that. Now I am intentionally doing this before I check if it's valid. And the reason for that is because whether it is valid or not, I want to make sure that the Blackboard reflects the current state. And this is actually really useful for then other things knowing, okay, you don't have a move location. So it's really handy. We don't just rely on the failure indications from the actual state machine itself. So that's good for the finding a location one. So then we have our move to. So again, this is going to be from state base. Get rid of all of those different ones. Now this again is going to have a navigation interface. It's going to have a stopping distance. So we also have our constructor for this. So it's reasonable for most of the stuff there. So in nav interface, we rename this. And we remember we want to support overriding the name for it. Base in custom name. So that's good. We've got those set up. That's going to keep it largely where we need. Now I can do the implementation. So, okay, when we enter, well, we need to attempt to try and move to this location. So what I'm going to do is firstly go and say, okay, well, let's try and actually get our destination. We'll have vector3 destination, and I'm going to default that to our invalid location. And then I'd say Blackboard, I want it to try and get, and we give it the constant, or sorry, names, and our move to location, and the output for that is destination. So that's good, and the default value that we can give for that is Common Core, constants, and our invalid vector3 position. So that's good. So, okay, if we've successfully retrieved it, then we're going to be able to do things with it. If we failed to retrieve it, then we will just exit out. So, okay, what we want to do then here is let's go and set, or attempt to actually set our move location. So for that, I do need the owner. So I need to get owner with Blackboard, and then my navigation has a set move location, and the set move location, I give it self, destination, and the stopping distance. So if that's succeeded, then I can just return that we are running. So fairly straightforward. We retrieve the location. If we did that successfully, then we just set that location. Now, that's looking pretty good. We could do an additional check here just to say if the destination is equal to our Common Core, like invalid position, then we'll return that we failed. So, because it could validly retrieve here, but the location is an invalid one, so we want to make sure we safely handle that. So that's good. In terms of our on-exit function, well, if so we've reached sort of the end of the moving here. What I want to do is firstly grab the self, because if we are still moving, then we want to actually interrupt it, because we could exit while we're actually mid-movement, so before we've reached the destination. So if our navigation is still pathfinding or moving, then we want to say navigation stop moving, like that. So that's good. And in terms of our tick, well, we want to, again, retrieve this. So, okay, there's a couple of key sort of things that we want to actually be doing. So if navigation is pathfinding or moving, and we provide ourselves, then we're still running. Otherwise, if we're at the destination, so if navigation is at the destination, then we're actually finished. And then the final scenario is, okay, we're not pathfinding or moving, we're not at the destination. That must mean that we have failed. So that's good. We've got our sort of key logic there for doing that. Then we have our transition that we were wanting to set up. So our transition inherits off of transition base. We know that we wanted to make sure it has a navigation interface. So that also means that when we set up the finished move here, it'll look like that. We do the implementation. So in terms of with this, well, this also needs to actually be able to retrieve self. So again, that's a common thing transitions all might need to do. So I'm going to add that helper function into this as well, just to, again, avoid duplication. So first thing I would do is self is getting our owner, and we provide the Blackboard like that. So we can say with this, and I can actually just do it in a single line. So if navigation is at the destination, then we return valid. Otherwise, we return invalid. So fairly straightforward. Not a lot to the actual sort of setup there for it. So if we go back to Unity, we want to check if we've got, if it's grumpy at us. And so far it is not, which is good. But there's going to be other things that we haven't sort of set up yet. So we've got our navigation interface that we need to actually populate. So that's what we're going to do next. So this is going to implement navigation interface. And it is still a mono behavior. So we don't want to lose that aspect of it. What we do need to do, though, is we need to get all of these implementations. So what I want to do with this is, because again, I still want to maintain the decoupling for this. So even though this is a concrete implementation, I want to try and have it that it's able to be fairly flexible. So what I'm going to do is I want to have a whole bunch of Unity events here. And this is going to look a little bit weird because so all of these are going to perform particular sort of functions. We're going to have the find nearest navigable, things like of that. So those ones are going to have a vector3. It's going to have a float for our search range, and this is the bit that is going to look weird, have this system action for a vector3. Now, the reason I have this is Unity events, you can send data with them, but you don't get a return value. But you can provide a function that can set things. And we'll see in a moment how I actually make use of this. So this is our onFind nearest navigable location. And I'm going to do a serialize field. So how this works is what I would do for actually making use of this is vector3 found position, and I default it to common core, constants, and our invalid location. Then I would say on find nearest navigable, I invoke it, I provide the search point, I provide the search range, and then I provide a lambda function. So the lambda function looks like this. I know it takes a vector3. So in found position. And then what I do is say found position is equal to that, and then I can return whatever that position was. So I pass a little snippet of code that sets a local variable. And that's a way of having a Unity event that actually can be giving you back information. It's kind of a sneaky way of doing it, but it works really nicely. So I'm going to have similar for our set move location. The main difference is that passes back a bool, and this is going to be on set move. Then I have a whole bunch of ones that are actually almost identical. So I'm going to do these all in one go. Serialize field. So these are all Unity events. These are our ones for basically getting back a Boolean. So all they have is system action bool, like that, and they will be on something function. So the first one is pathfinding or moving. The second one is at destination. And our final one is our stop moving function, like that. So then for linking these up, it's going to be a very similar process for all of these. So we have bool, our result is false. So I'm not using the mover at this stage. It's there as a thing that I might use later on. So return the result, and we follow the same sort of pattern. So we invoke this. We just need to provide it with a bool in result, and incorrect. It's getting grumpy because I missed that. So that's all we need to do for those ones. Make sure it didn't include any ones that it shouldn't. Nope. So these, all that's going to change for the ones that just give back a bool is I just need to on is pathfinding or moving, and same thing for the stop moving. So very straightforward. Set move location isn't much different. The only difference here is that I also need to provide the destination and the stopping distance, like that. So that's it for the navigation interface. It keeps it nice and straightforward, keeps it simple. And if we go back here, so these will need to be linked up to things, and we will link those up in a moment. But this sort of keeps it straightforward, simple, makes it easy to work with. So far so good. Now the brain wrapper is kind of the last thing we need to get implemented. So this is a GOAP brain base, like that. Can nuke all of that. We'll let it implement the default ones here. So we've got our stuff for configuring. Now I do want to keep track of our navigation interface that we're actually talking to. So this isn't our sort of core navigation. This the navigation interface. This is actually the lower level one. So this is where we are introducing a bit of a dependency. We could move that dependency further into the navigation side at a later stage, and that is something that I will do as a future improvement. But for now, we're going to have our base navigation, and this is going to be our nav system, like that. So that's going to be something we connect to. So in configure brain, we will do nav system, and we're going to retrieve that from the game object that we're on. Now, in terms of configuring the Blackboard, there's nothing custom that we need to add in at the moment. But what we do need to add in support for is all of these functions here that are being called. So we need to sort of do the bridge between these functions and the navigation system. So that's reasonably straightforward in terms of what these need to actually look like and what they need to do. So all that stuff disappears. These end up being public functions. And we will bring the names over. So this is our find nearest. So that will take a vector 3 for the in search location, in search range, and our system.action is our in callback function. So that's going to be the common pattern for all of these. So none of these return anything, but this is sort of the setup that they'll all follow. So we'll do the same thing for set move location. Say, so void that. We'll have our destination. We have our stopping distance. And again, we have our callback function. Very similar logic for all of these. So these ones get the same treatment. I'll actually do these ones a little bit differently, just because it's going to be a little bit cleaner and neater. So we can nuke all of that. They're all void, because these only have that callback function. So these just have system action bool in callback function like that. That's good. Doesn't do the braces so nicely when it's doing multi-line editing, but that's fine. So, okay, let's link up all of these. There's not too much that these actual ones do. They're mainly just a bridge into the navigation system. So what we would do is if nav system is null, which could happen, we just want to make sure we handle that. So we run our callback, common core, constants, and our invalid vector 3 position, whereas these other ones will all follow a very similar approach. The difference is that they will run the callback but provide false because it's failed. So we just do that for each of these. So that's good. And then we can start to link up the actual specific logic. So stop moving function would do nav system stop movement like that. And what we would then do is run our callback with true. Is at destination? Well, that is just going to run the callback and say, well, okay, hey, nav system, are you at the destination? Pathfinding or moving, also pretty straightforward. We run the callback we do nav system, and then we ask it, is it finding or following a path? Setting the move location, also pretty straightforward. There's not a lot that we need to do with that. What I would do is keep track of the result from doing nav system and setting the destination. So set our in destination. if the result was successful, then what I would do is say, okay, well, nav system, set the destination reach threshold, run our callback with true. In callback function, like that. Otherwise, we just return false. So callback function, false. So very straightforward, not a huge amount that it needs to actually sort of do with that. And then our find nearest navigable is not much more complicated. So we have our vector3 found position. So we're going to default that to constants and our invalid position. Then if our nav system fails to actually get our nearest point, so we give it our search location, we give it our search range, and then we have found position. So if it fails, then we run the callback function and we just provide, again, our actual invalid location. Otherwise, if it was successful, which we could flip this around and actually remove the not from here, and instead what we would do is if it was valid, then it just provides found position. So that's good. That's all we really need in the wrapper side of things at this stage. So we can actually then link up these functions, because these all link to the brain wrapper. Now this is something where it is a little bit manual at this point. Again, a later stage thing that I want to add in is making this cleaner and neater. So, okay, in terms of the function, we're looking on the GOAP brain wrapper, and we've got a dynamic one there. So we just link up each of these individual ones. Now, when we're getting to these ones that just work with a bool, we do need to be careful because it would be very, very easy to accidentally select the wrong one because there are multiple. So this is our is pathfinding or moving. This one is at destination. And then we have our stop moving function. So that looks good. So we've got our basic setup there for it that in theory should mean if we run this that it can actually just wander around. So let's test this out and see what might break. So we'll run it. So you can see it's wandering. You can see the position here and where it's heading to. So it's reached close to the position. You can see that it's waiting. Once it's finished waiting, picks another location, starts moving to it. And if I bring that here, and we can just watch it. So we have our first set of basic behaviors going. We have our ability for it to wander around, for it to pick locations, for it to wait there for a random amount of time. So we know that our brain setup is working, and we know that our action and goal setup is working, and we know that things like the key stuff for the navigation interface is working, which is great. So we've got a whole bunch of our setup there working for these actions. So there are going to be future videos coming up in the next couple of weeks. With each one, I'm going to be filling out further of the actions. We will likely make some further updates and modifications to things like the different states that we've already set up for navigation. There are going to be some extensions we add, but we've got our core setup there up and running. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out. Really appreciated. If you're looking for the code for the project, there are 3 links in the description below. One is to the code as it was at the very start of this tutorial. The other is the code as it is now. And the final one is a link to the completed package if you're wanting to just dive straight into that. So that's all available. If you have any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description also. But until next time, bye.